I'm going to share my screen for section 13.5, and today we're mainly going to be talking about the volume. We're also going to be talking about some conversions and then measures of mass and capacity. So the volume is how much an object can hold. So I want you to think about it, it's like three-dimensional. It's like a capacity thing. So if I was just going to talk about volume in general with these two figures here, I see that volume, if we counted each of these as one unit squared, cubed, this is one cube, this is two cubes, this is three cubes. Under here would be four cubes, and under that guy would be five cubes, six cubes, seven cubes, eight cubes, nine cubes. So this is 9 cubes, so its volume is 9 cubic units. Same here, 1, 2, there are 3 under there, 4, 5, 6, 7, 8, 9. They have the same volume. These little cubes rearranged. But as far as surface area is a little different. Surface area is like the squares that are showing on the outside. Like if you're going to wrap present, it's the area that you would cover. So I see that I have 1 here, 2, 3, this on the bottom, 4, and to the left I would have 5 here. And then 6 here, 7, and then the one on the bottom, 8. One on the bottom here, 9, 10, 11, 12, 13, one on the bottom, 14, 15, one behind, 16, 17, and then I have 18, 19, 20 behind, 21, 22, 23, that one behind there would be 24, 25, 26, 27, back in here, 28, 29, and then underneath these two guys, you have 30, that's where you get 30, 31, 32, and then the bottom, 33, 34. So that would be 34 square units. Whereas if we counted all of the faces here, we would get 36 square units. Notice that volume is measured in cubic units or units cubed because it's three-dimensional. When you have a volume, you have a length, you have a width, you have a height. It is 3D, and so each of those things have some measurement of a unit. And so when you multiply unit times unit times unit, you get unit cubed. Versus area is just unit here times unit here, so it's unit squared or square units. So area, square units, volume is always measured in cubic units. Volume of a rectangular prism is length times width times height. Some people say the area of the base times the height. They're the same thing. Here are some conversions. So 1 decimeter cubed is the same as 1,000 centimeters cubed because 1 decimeter is the same as 10 centimeters. So if I did 1 times 1 times 1 here, I got 1 decimeter cubed, but here I got 10 times 10 times 10, so I have 1,000. Meter to centimeter, and 1 meter, there's 100 centimeters. So this is showing you that conversion there. Here's practice, convert each of the following. So we did another unit similar to this a little while back, but if I want to convert meters cubed to centimeters cubed, I think the easiest thing to do is to make unit conversions. So you're going to multiply by forms of 1. That is why they're called unit conversions. And the easiest thing to do is whatever this guy's units are here, you want them to be in the bottom here. Okay, that's going to make it cancel. So I'm going to have my meters cubed on the bottom. I'm going to put 1 meter cubed. 1 meter cubed is equal to how many centimeters cubed? Again, 1 meter is 100 centimeters. So it's not just going to be 1 meter cubed is 100 centimeters cubed. It's going to be 100 times 100 times this 100. You're going to have that multiplying factor where it's cubed. So you have 100 times 100 times 100. So that's 1 with 1, 2, 3, 4, 5, 6 zeros after it. 1, 2, 3, 4, 5, 6. So that means we're multiplying, and that is centimeters cubed. This is a form of 1 because a million centimeters cubed is the same as 1 meter cubed. And then when I multiply across, these meter cubes cancel, and I get the 5 million. Here, similar, except we're going to do millimeters. Okay, so I'm going to put my millimeter on the bottom, and I have to think about this. Okay, so 1 centimeter has how many millimeters? 1 centimeter is equal to 10 millimeters. So if I had 10 by 10 by 10, that's going to be 30. So then I need to put that, I mean, not 30, but I added on accident, 10 times 10 times 10 and not 30. That's one with 3 zeros or 1,000. So that's 1,000 millimeters cubed or in 1 centimeters cubed because they're 10 in every centimeter and you're cubing that or you're multiplying that 10 by itself those 3 times. So these cancel and then I could cancel out 1, 2 zeros and I'm dividing by 10. So that means I need to move the decimal over from here to here. So that's where we get the 12.3 centimeters cubed. Liters, okay, a liter, 1 milliliter is the same as 1 centimeter cubed. So sometimes when we measure volume, if it's a liquid, we measure it in terms of milliliters and liters in the metric system. So 1 liter is the same as 1 decimeter cubed or 1,000 centimeters cubed. And here are some units to just keep in mind. Kiloliter is 1,000 liters, hectoliter, 100 liters, deciliter, 10 liters, liter, 1 deciliter is 0.1, 0.01, and 0.001. So 27 liters. So you're going to use this chart over here. And we're trying to go from liters to milliliters. So let's find milliliters to milliliters. Hard to say. Okay, so it's 1,000 milliliters in 1 liter. So if I want to convert that, I have 27 liters, and then I know from that chart there are 1 liter, there's 1,000 milliliters. I multiply this, and so then I get this 362 milliliters. So if we put that, or it's the same idea, so 362 milliliters, I know there's 1,000 milliliters in 1 liter. Again, you want this one to be on the diagonal so that those unit conversions cancel out and you're left with the liters. So this is 362 divided by 1,000. When you divide by 1,000, it's like you're moving the decimal back 3. So that's 0.362. This is using the fact that 1 milliliter equals 1 centimeter cubed. So these are equals to one another. And then 3 meters cubed. And then let's look back at the meters cubed. The liters. So we have 1 liter is 1,000 centimeters cubed. Okay, 1 liter is 1,000 centimeters cubed. Okay, so I'm going to convert this first to centimeters cubed. So in 1 meter cubed, how many centimeters cubed do you have? Well, let's think about it. I got in 1 meter, I have 100 centimeters, and this would be 100 centimeters, and then it would be another 100 centimeters. So I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then I'm going to say, okay, there's 1,000 centimeters cubed in 1 liter. And so I could simplify this and just take 3 of these zeros, 1, 2, 3, mark out those 3. And so then I realize that I'm multiplying 3 times 1,000, and so I get that 3,000 liters. And again, with the unit conversion, I just want to reiterate. I put meters cubed here so that these cancel, and then I put centimeters cubed here so that these cancel. And each of these are forms of 1. These things equal one another. 1 liter is the same as 1,000 centimeters cubed, and 1 meter cubed is the same as 1 million centimeters cubed. So that's the key concept of unit conversions. Basic units of volume, you have cubic inch, cubic feet, cubic yard, and here are volume equivalents with English measurements. So this is what we usually see here in America, 1 gallon. It's 231 inches cubed. 1 quart is 1/4 of a gallon. Convert 45 yards cubed, feet cubed. So they're showing you what to do. Like I've been explaining, I'm going to show you as well just to talk through it. We're starting with yards squared here. So that means I want to put yards squared on the bottom. and I want to go to feet squared. So I have to think, let's think about this. I know there's 3 feet in every yard. Oh no, not squared, it's cubed. Put that down. Okay, there's 3 feet in every yard. So if it's going to be cubed, I need to do 3 times 3 times 3, which is 27. And so now these yards will cancel, and you'll be left with that feet cubed. So when you multiply 45 times 27, you get this 1215. So for this is going inches to yard cubed. So 4320 inches cubed. I'm going to put inches in the bottom. So inch, like instead of doing this 1 over 36, I'm just going to say there's 36 inches in 1 yard, but I need to cube this if I'm doing yard cubed. So 36 cubed, whatever that is. So put it in your calculator. If you divide 4,320 divided by 36 cubed, you're going to get this as your answer. Again, you're cubing it because we're talking about volume. More examples, 10 gallons. So in 1 gallon, they told you in that a few slides back, there's 231 inches cubed. And then in 1 inch cubed, again, instead of writing it like this, that third step there, I would usually think about it like this, 10 gallons, and then we have 1 gallon. Again, the gallons here, so it cancels, is the same as 231 inches cubed, and then you got inches cubed down here. 12 cubed is going to be in 1 foot cubed, okay? Because in 1 foot, there are 12 inches. And if you do cube, you have to do 12 times 12 times 12. And so you're going to be multiplying 10 by 231 and then dividing by 12 cubed. So it's 10 times 10 to 31 divided by 12 cubed. And when you do that, you're going to get 1.337. So an idea here, 3 feet cubed, in 1 foot cubed, or not, let's not be 1, 3, so in 1 yard cubed, and each yard there's 3 feet, so this needs to be 3 cubed feet. So one of these 3's would cancel with one of those 3's, and so you're going to have 3 squared on the bottom, which is giving you that 1. Volumes of prisms and cylinders, 2 solids, each at the base in the same plane, have equal volumes if every plane parallel to the bases intersects the solids and cross sections of equal area. So that is illustrations of that. So when we find the volume, it's length times width times height, or it's the area of the base times the height. So how do I find volume of these things? Here, it would just be 6 times 6 times 6. You guys have 3 dimensions for volume, and that's going to give you this. Here, you can do the area of the base times the height. But the area of the base would be 3 times 10, so 30 times your 15, and so you get this, and don't forget it's always cubed when you're doing volume. For a cylinder, it's the area of the base, which is pi r squared. For a circle, so pi times 5 squared. 5 squared means 5 times 5, and 5 times 5 is 25, times the 10, so that's where we get the 250. And all of those, it is the area of the base times the height. For a pyramid, it's 1/3 the area of the base times the height. And then for a cone, it's 1/3 pi r squared times the height. So if I wanted to figure this out, 1/3 area of the base times the height. 1/3 area of this base is 16 times the height, which is 5. And so what do you get? You get the 80/3. And then this one is 1/3 I r squared h. So r stands for radius, which is this distance from the center to the edge. So that's your r. So 1/3 times by pi. 6 squared times your height. And notice it didn't tell us our height. So this is pulling back from the Pythagorean unit that we just did. This, we have to get our height. Height is the one perpendicular. This is not the height. This is the slant height. It's not the height of the cone. So how do I figure out what this is? Well, that is like b in your Pythagorean theorem. So 6 squared plus b squared equals 10 squared. Or if you remember the trick that really helps, it's 3, 4, 5. This is 3 times 2. This is 5 times 2. That makes this 4 times 2. So that means this missing height is 8. And if you multiply 36 times 8, pi over 3, you're going to get 96. So 3 divided by 36. I mean, there's divided by 3 is 12, and 12 times 8 is 96. You get the 96 pi. So if they don't tell you that height directly, you can find the height by using Pythagorean theorem. Find the volume of the pyramid represented below. So pyramid is the 1/3 area of the base times the height. So how do I find the height of this? That's the question. Height of this. Tricky. On the area of the base, so they got the square root of 50 as the height. So let's draw it like this and see if we can figure out what it would be. Okay, so here's my 10. I want to know what this is right here. So we need to figure out what. Okay, now this is 10 and this is 10. This is 10 root 2. This will be 5 root 2. That's 5 root 2. And then this is, oh, it's triangles equilateral. So then this is 10. Okay, so I have 5 root 2 and I have 10, and I want to find this height right here. That's my height. So I'm going to do a squared plus b squared equals c squared. So 5 root 2 squared plus height squared equals 10 squared. So I got 5 squared is 25 and root 2 squared is just 2. 10 squared is 100, and then this is 25 times 2 is 50. So I'm going to subtract the 50 over. I get h squared equals 50. And so h is the square root of 50. So then this is the formula, 1/3 area of the base times the height. The area of the base is the square area, which is 10 times 10, which is 100. And then the height is root 50, which is what we found by imagining holding up that pyramid and figuring out what that height is by making it that missing side of the right triangle. We found that the base was half of this hypotenuse. And here I use 45, 45, 90 triangle we talked about a little while ago. Like if this is 10 and this is 10, then this is side root 2. And we cut that in half, so it was 5 root 2. So that one is a little tricky for sure. But that is how you do that one. Let's see, volume of spheres, 4/3 pi r cubed. This is just an example of one. It's really simple to use this one because there's only one variable, the radius. So to actually find the volume of spheres, you just have to know the formula, 4/3 pi, and then it's r cubed. And as long as you know that formula, it's really simple to plug into. All right, let's talk about that. What is the surface area of a sphere? 10 inches in diameter compared to the surface area of a sphere, 5 inches in diameter. Any two spheres are similar. The ratios of the diameters are 10 to 5 or 2. The ratio of the surface areas is 2 squared or 4. The 10-inch sphere has 4 times the surface area of the 5-inch sphere. So that's what this was saying here, that similar polygons, they have a scale factor of k. The ratio of their areas is k squared. So in this case, 10 to 5, that's linear, and that's a scale of 2 more. So if we're talking about areas, you square that term. So it would be 4 times more. And that's a volume of a sphere, 10 inches compared to the volume of a sphere that's 5 inches. Okay, so what's the multiplying factor between 10 and 5? The multiplying factor here is 2. But if we're going to talk about volume, you have to realize that that is cubed. That's a 2 here and a 2 here and a 2 here. That's 3 dimensions of 2. And so that's why you take this multiplied factor and you cube it. Mass, this is the definition, mass, a quantity of matter. So here are some other units to learn: metric ton, kilogram, hectogram, decagram, in relationship to a gram. And so if we do unit conversions, it's very similar. 34 grams. Well, how many grams? It's 1,000 grams are in 1 kilogram. So if I write that out, 34 grams, and then I'm going to put the grams down here. I'm going to try to figure out how many grams are equal to, well, there's 1,000 grams in 1 kilogram. And so these grams cancel, and then you get 34 divided by 1,000 as your answer, which basically means you're going to take that decimal and you're going to move it over 1, 2, 3. So that's how you get the 0.034. And then kilograms and tons. Okay, so 1 ton is 1,000 grams. And 1 kilogram, no, sorry, is 1,000,000 grams. And 1 kilogram is 1,000 grams. Okay, so let's see. One, what I said. So kilogram and gram, 1,000 grams. 1,000 grams and 1 kilogram. So in 1 kilogram, there are 1,000 grams. And then that I convert that to tons. In 1 ton, there's 1,000,000 grams. So in 1 ton, there's 1,000,000 grams. Now again, I'm putting kilograms here, I want to cancel, and the grams diagonals cancel. So I can simplify, there's 3 zeros here, I can knock off 3 zeros here. So basically we're taking this and we're dividing it by 1,000. Or you can think about that as taking this decimal, moving over 1, 2, 3. That's why we get this as our answer. Um, 1 centimeter cubed, 1 milliliter of water is equal to 1 gram. 1 decimeter cubed or 1 liter of water is equal to 1 kilogram. So this is just a relationship between like weight and volume of liquid. So these things are equivalent to one another. So a water that measures this amount, how many liters of water can it hold? Well, in order to find the volume, I would multiply length and width times height. And then we know, because it just told us, that a centimeter cubed is the same as 1 milliliter of water. And so I know that these are going to be, I divide by 1,000 because the cubic, right? So I got my answer of 756 liters. What is the mass in kilograms when it is full of water? Because 1 liter of water has a mass of 1 kilogram, 756 liters of water have a mass of 756 kilograms. So if we look back here again, 1 liter is equal to 1 kilogram. So if I have this in liters, that's how many kilograms it's equal. If I wanted tons, I would have to divide by 1,000, which is what they got there. I know that's a lot. Hopefully that was helpful. You can always pause it and rewind it and slow it down. Attempt your assignment, and as always, please reach out with any questions.